Good afternoon and welcome, dear friends, to the EduSat live lecture in the science stream. Today we have with us Professor D.K. Lobial from JNU, who is from the Department of School of Computers and Systems Sciences. He is going to continue the series on computer networks, and today he is going to talk about physical layer of computers. So we welcome Dr. D.K. Lobial. Welcome, dear sir.
Thank you, madam. In previous lectures, we have talked about how a computer network works and what are the requirements for a computer network to do. And we also talked about the various layers of computer network. So, when we went through the OSI model, we talked about 7 layer models, and when we talked about TCP/IP, we talked about 4 or 5 layer model. So, one of the important layer, or you can say the lowest layer in the hierarchy, was physical layer. Now, today we will be talking about what are the various objectives of this layer and what are its functions, and then how this layer performs its functions. So, let us begin with this. What are the objectives? So, the primary objective of physical layer is to transmit a signal from one system to another system. So, at the lowest level, because it is a signal transmission, and then to transmit a signal, it is important to decide what is the appropriate signal which is suitable for a transmission medium. So, we cannot send any signal whatever we like. So, that is also one of the objectives of the physical layer. Then even if we have decided that what is the signal which is suitable for a given medium, then we have to decide the various kind of devices that are required to make this communication possible. So, these 3 objects, there may be many more, but these are primarily 3 objects which I have defined as objectives. Now, how to meet these objectives? What are the various functions that a physical layer has to perform? 1, see if you have decided what is the medium and what are the devices to be used. Now, the primary question is that you have to provide an interface to transmit the information, and then refine, because you have to define the rules by which bits are passed from one system to another system, because in a computer system the information is stored in terms of bits. If you go to the other layer, data link layer, or from the top layer, all information being passed from the topmost layer, which is an application layer, is being forwarded in terms of digital bits or bits to the lower layer one by one. When it comes to the physical layer, that means what we are obtaining or getting at the physical layer is a sequence of bit patterns which represents the information to be transmitted. Now, this sequence of bit patterns has to be transmitted, and to do that they are to be converted into a signal form, because ultimately at the lowest level it is the signal which will travel from one system to another system. Now, therefore, one of the important function becomes what kind of a mechanical specification we should have for the connectors, for the cables, and what should be the electrical function specifications, what should be their functional specification. The meaning hereby is, if I have to put a connecting device or a connecting interface, then I must see that how many pins must be there. If you look at when you connect some cable with some your TV or something else, you will find there is a connector, there are certain pins. Then how many pins must be there in a connector? And what should be the size of a connector? What shape the connector should be? So, you look at different kind of connectors at while you are connecting a TV or you are connecting a fridge with something else, you find that there are different kind of connectors which have different shapes, which are different size. So, their dimensions, shape, size will tell what should be the mechanical interface. So, there remains a compatibility between the device which is being connected or the device to which it is being connected. In addition to that, when there are pins, now we have to see how many pins. That is where the number of pins will decide that which pin will do what. That means, if a connector has 4 pins, maybe one is used for transmission of a signal, one may be being used for receiving of a signal, other may be for grounding, other may be, say for example, to provide some kind of control information. Now, that is what I am saying, in addition to the number of pins you decide, then you have to decide that what function or role each pin has to perform. As I said, One will be used for transmitting of signals, other may be used for receiving of signals, and some may be for grounding of signals, so and so forth. And therefore, now when you say this, you have specified the mechanical, electrical and functional specification for the devices you use at the physical layer. Now, the question comes, when you transmit a signal, now what level of voltage will represent what bit and what signal and what information. So, the timing of the signal is equally important. What time a signal comes, what does it represent? So, that is why it says the characteristics such as voltage levels, timing of the voltage changes when the voltage should change, and the physical data rates, at which rate the data should travel through the medium. So, maximum transmission distance to which a signal can travel is important, and then physical, so and so forth. So, there may be various other attributes. When you transmit a signal, say for example through a cable, then how long the signal can travel, that is very important, and where does it terminate. Other function may be that if the signal becomes weak while on travel, because it will keep on losing its strength, I will talk about that. So, therefore, when a signal loses its strength, then what, and the signal loses, then the signal has to enhance, the strength of the signal has to be enhanced. And while a signal is being transmitted or it is on transmission, there may be some undesired or unwanted signal may interfere with the signal, and that is what we call a noise. And noise is defined as undesired or unwanted signal interfering with your signal. So, the noise may be added into a signal, and when the signal travels and at the receiving end you receive or you obtain a signal which is with the noise, and due to this noise probably you may not be recognized or may not be able to recognize or may not be able to determine what information actually the signal is carrying, because the information has been mixed up. So, therefore, one of the role may be to filter out the noise. So, noise has to be separated out from the signal to identify or to get the meaningful information contained in the signal. Now, that is what, if you look at this diagram, I have been. So, what happens at the physical layer level, these systems are connected. If you put that to the end system alpha and the right side is end system beta, they are connected, and then there are two more systems in the middle, which is we call, I am not given a name, they may be say routing devices. So, the physical level of system alpha is connected with the system B in the middle, and then the system next to the alpha system is connected to next to it, and then finally it is to beta. So, at each level the physical layer connections are there. Now, so that means if you look at what are the various functions of physical layer in toto, if I am showing and to summarize, so what you find is one of the function is modulation. I will talk in detail, but the modulation is you have to modify a signal so that it can be transmitted. Then that has to be decided by the physical layer, what kind of modulation techniques are to be used for transmission of a signal. Then what kind of a line encoding techniques to be used, that is bits to digital signals. If there are bits used, then they have to be converted into digital signals. So, bit to signal, signal to bits, and then modification of a signal. So, encoding schemes and the modulation techniques are very key functions of physical layer. Then how long a bit will last? When you transmit a signal, if the signal remains constant for a while, then how long it will be considered 1 bit or it will represent more bits. So, the bit interval is important, that which duration of a signal timing you will call it a bit, and therefore, that will define a bit rate. What is the bit rate? That means how many bits are being transmitted per second is called a bit rate. So, sometimes the student get confused with bit rate and baud rate. Baud rate is defined as the number of signals change per second, is called a baud rate. Now, before I go in detail, and the number of signals or bits transmitted per second is a bit rate, and the number of signals changing per unit time or number of signals changing per second is called a baud rate. So, in normally the bit rate is more than baud rate, because one signal may change may represent more than one bit, right. So, for example, if there are a signal changes 3 times or say 8 times. So, to represent each change we need 3 bits. The first change may be 000, second may be 001, third may be 010, fourth may be 011, and then fifth may be 100, sixth may be 101, seventh may be 110, then last one may be 111. So, I need 3 bits to represent a signal change, and then if there are say 8 changes in a signal, so 8 multiplied by 3, because each represented by 3 bits. So, 8 changes in a signal in 1 second is represented by 8 into 3, that is 24 number of bits, because each change is represented by 3 bits. So, therefore, what I said is, in a normal course the baud rate is lower than bit rate, or the bit rate is higher than baud rate, because in this example what I quoted here, your bit rate is 24 bits per second, where your baud rate is 8 signals per second, because there are 8 changes. So, that is how you have to see. Then whether the bits are transmitted serially or parallelly, or the communication link which is being used is a half duplex or a full duplex. When I say half duplex, that is only out of 2 participating or 2 communicating pairs or peers, whatever you want to say, only one will be able to transmit at a time. When one has transmitted, the transmission by A to B is over, then B will be able to transmit to A. So, one at a time, that is all called half duplex. That is what the walkie talkie you hear, one person talks and say over, then the other side talks, that is half duplex. Full duplex, that is both sides are able to communicate simultaneously, like you call in a telephone, you speak, the person on the receiving side also speaks. So, both are speaking and talking simultaneously, that is what you call a full duplex. So, the physical layer has to decide whether the communication will be full duplex or half duplex. As I said, how many pins and then how many connections set up, and connections will be set up and how many connections will be torn down, that is what basically the physical layer does. Now, before I go in that detail, as I said, the signals that is traveling, that one of the basic how it works now, I said the information from the top layer is coming in terms of a pattern of or a sequence of 10 forms to the physical layer. So, therefore, if I assume that I am using some electrical mediums where the electrical signals will be transmitted, then these bits has to be converted into electrical signals. So, the bits coming from layer 2 to layer 1, that is physical layer, are being converted into electrical signals. Then these electrical signals are transmitted over a communication channel, because channel is very important, because channel has its own properties. And then when these signals fall weak or they become weaker as they travel, and then we need to amplify them, increase their strength. Now, therefore, 2 terms I will introduce here is, one is called attenuation. As the signal travels through a medium, it loses its power. If you are transmitting a signal of say 10 volt, and it will, as it travels, it will keep losing its strength, that is what we call attenuation. That means signal will keep on attenuation, and then after certain distance it attenuates to such a low level that you need to amplify it, increase its strength. I will give a very good example. Now, if you say while I speak that my voice can reach only to a certain distance, and beyond that, if some person is standing beyond that, he or she will not be able to listen to me. If you leave aside this communication, I am talking of open communication where I am not using any electronic medium. Now, this depends on if I speak louder, that is if I use more voltage, that my voice will reach to a more distance, but there is a limit. I cannot shout beyond a limit, that is what the maximum capacity I have got. So, therefore, the maximum, if I shout with the maximum loudness, I use the maximum energy to shout, my signal will reach to some maximum distance, otherwise it will reach less than that distance. So, that is the maximum distance my signal can travel if I use the maximum energy to transmit a signal. And it goes, it keeps on reducing its strength, that is why it has a limit, after that it cannot. So, and keep one thing in mind, and that is what we call attenuation. But to a certain distance, the signal can be detected, and but to a certain distance the signal can be only sensed. The moment I say detected and sensed, it has two differences now. Now, when my voice reaches to a certain distance and everybody within that distance is listening to, they will be able to listen and able to make out what I am talking to, even if they do not listen, but they know what words I am talking to. But after a certain distance, my voice will reach to that point, but they will not be able to make out what I am talking about. So, that means till the point where I am being heard and the words what I am talking are identified or recognized properly, that is called a detectable range or distance. But beyond that, if my voice is heard, but it is not made out what I am talking, is called sensible. You can sense, but you cannot detect. So, here the detection distance is important, where you can make out. After that, you have to enhance or amplify the signal strength. Now, one we said that there is attenuation, and second we said there is what you call is noise. Now, before we go in that detail, let me talk about other working of the physical layer. Other parts is that encoding it has to do, that bits convert to, then modulation as I said, and there are some standards given RS-232 and 422 which are used to connect to devices serially, and then we use amplifiers, we may use repeaters. If it is digital communication, we use repeaters. If it is analog communication, we will use amplifiers. Then you may be hearing something called hub. Hub is a kind of repeater, and we use them to connect systems to a longer distance. Now, here we will talk about what should be the signal rate or the data rate, right. Nyquist has defined a signal rate or a data rate provided a signal. The signal has some bandwidth, that is a difference between the maximum frequency of a signal and minimum frequency of a signal is called a bandwidth. Now, when I speak, I am generating a sequence of frequencies or a composite. I am not talking at one single frequency. I mean any human being when talk, you may be speaking, if I put it from 0 to the maximum frequency may be 8000 or 10,000 hertz per second, and loudness does not have anything to do with the frequency. So, when I speak, I am generating certain signals of certain frequencies. So, it is a composite signal where the signals varies from 0 frequency if I put it to up to 8000, maybe maximum 10,000 if I shout, or if I use more, then I may be now. If I put that range of the signals and the maximum frequency if I say 8000 and minimum 0 if I put that way. So, the bandwidth is 8000 minus 0, that is 8000 hertz is my bandwidth. But even voice, if you look at telephone, in the books you may be studying that we use a 4 kilohertz bandwidth. What you assume is that the voice signals which talk, that I am talking right now, the information part of the voice signal is contained only between 300 to 3300 hertz. Rest may be fine tuning and improving the quality of the voice, but the information part, what carries the information, is contained between 300 hertz to 3300 hertz. So, if you 33 minus 300, that is 3000. So, the actual bandwidth in which information of the voice will be transmitted is 3000 band. I need a signal where it can carry a frequency of 3000 hertz. So, the information will be carried. But when we have to have multiple users simultaneously, then we need certain gaps in between, because one will send from frequency this to say for 300 to 3300, then another has to also, then we will combine them, multiplex them. Then what will happen is there should be a gap between two channels. So, 1000 gap. So, 3000 plus 1000, 4000. So, therefore, in the books while you read, you say a voice quality signal or a voice signal, voice grade signal has a bandwidth of 4000 hertz or 4 kilohertz. Now, then we have to compute the data rate, and what you say in Nyquist state is 2 into h log v base 2 bits per second. That means, if a channel of h bandwidth is being used and a signal is using v different labels, then the total amount of bits you are transmitting is 2 h into log v base 2. These are the number of bits, and with example I will tell you, if I have a 3 kilohertz channel and channel cannot transmit binary or can only transmit binary signal, say for 2, not cannot, it can transmit only 2 labels, then the voltage labels are 2 and the signal is 3K, and then it is 2 into h, 2 into 3K, 3000 hertz, 2 into 3000 into log 2 is the 2 labels and base 2, and it gives around 6000 bits per second. So, what is said is now the total the bit rate is 6000 bits per second. Now, that is important. So, the bandwidth plays a key role, even if you say that how many bits you can send per second. Now, this is when the channel has no noise. That means, whatever signal I am sending, it attenuates, but there is no noise which intervenes with this. Now, if there is a noise, because the noise is not in our control, say for example, if you transmitting a radio signal and there may be a lightning in the sky, and that is an undesired signal, it may interfere with your signal, number one, or second, while your signals are travelling, there may be another signal also travelling. Now, in that case, the bit rate will be lesser. So, that is given by another formula by Shannon, which said the maximum data rate is given by h log 1 plus Ps by Pn, where h is the total bandwidth we are using and Ps is the signal strength and Pn is the noise strength. So, noise has its own power and signal has its own power. So, h is the bandwidth. So, bandwidth into log 1 plus SNR, which is called signal to noise ratio, that is Ps by Pn, which you call signal to noise ratio. So, signal to noise ratio becomes very important. Why? So, therefore, signal to noise ratio, if it is more, that means I will get the higher bit rate. If signal to noise ratio, that is Ps by Pn is lower, then I will get lower data rate, because Ps by Pn, if I take it if it is lower than h into this log Ps by Pn will be smaller. If Ps by Pn is more, then log of this will be higher. So, multiplied by h, the higher bit rate. Now, take an example, if you have a signal of 3000 kilohertz channel with a noise ratio of 20 dB. So, noise is represented in dB, decibels, 30 dB, then Ps by Pn will be 1000. Why it will be 1000? So, SNR is 10 log 10 Ps by Pn, which gives in dB. So, that means what? SNR is 30 dB, that means 30 dB is equal to 10 log 10 Ps by Pnr. So, 30 log 30. So, if I divide 30 by 10, it becomes 3 equal to log 10 this Ps by Pn. So, therefore, Ps by P1 will be 10 raised to the power 3, which is 1000. So, Ps by Pn simple ratio is 1000. It will be a dimensionless, because Ps is in watts and Pn is also in watts. So, both will cancel out. So, there is no dimension. So, Ps by P or SNR or Ps by Pn is a dimensionless quantity, whereas I convert into dB. So, 1000. So, therefore, Ps by Pn is 1000, and then if I compute this, so it becomes 3 into log 1001 base 2, and if you compute this, it will become almost 30,000 bits per second. So, because this log 1000 may be something like 10 or 100 and then something, then 3000 multiplied, it becomes 30,000 kilobits per second. So, now the signal to noise ratio is important, because if you look at this, when I speak and somebody else sitting next to me also speaks, it may not be audible to the people who are listening to. Now, what does it mean signal to noise? I am supposed to speak, so this is a signal. So, the energy what I use in speaking is called signal strength, and the person sitting next to me, if he simultaneously speaks, whatever he speaks is a noise, and that also has a energy. Now, if my signal strength is more and his signal strength is low, the ratio is high, therefore, I can be audible. So, if he is only whispering, then it will not make a difference and you will be able to listen to me, because the whispering has a very low energy. So, noise signal has a low energy, and while I am speaking, it has a higher energy. So, ratio becomes high. So, still it is manageable. But when he increases his voice or his signal strength, it keeps on, then Ps by P will keep on reducing at a point which we call a threshold. At a point it will reach to a level, it will be creating a noise and you will not be able to make out what I am speaking. So, signal to noise ratio has to be kept low to get a quality signal. Now, so there is attenuation, and we represent attenuation in terms of dB, and we also represent amplification in terms of dB. So, amplification is when the signal received is stronger than the signal transmitted, that is what we amplify signal. So, one signal which I am transmitting, the transmitted signal is P1 and received signal in watts is P2. That means I am receiving P2 by P1, and if it is more, then probably I will get a good one, a quality signal, I can make it out. Now, while transmitting these signals, the medium is one of the key issue. Now, why this is the issue is, while I am speaking, and this is a voice signal, and this is a mechanical signal, because when I throw the air, speak, and the sound comes to the air, and because of the motion of the air particles, the sound is travelling from my position to the straight to the other position due to the motion of the particles of the air particles. If there are no air particles, the sound will not travel. That is why sound will not travel in a vacuum where there is no medium. So, the mechanical energy always needs a medium to travel. So, if this voice has to travel to a longer distance, it cannot travel, because my voice cannot be heard in the next room itself. So, it is a very short range. So, if I try to transmit these voice signals, I probably through a computer, if I record my voice, this voice will be recorded into bit forms. That means, when you speak on a mic, the computer will convert these signals into 10 bit pattern. That is what we call a digitization, because my signal is an analog signal, because it is continuous signal with respect to time, which will be converted into bits of 10 or digital form. That is what we call digitization. So, that means we need a software which does the task of a digitization, and then the digits or bits are stored in the computer in terms of bits. Now, so therefore, when this has to be transmitted, and then I have to convert this into electrical signals. So, I have devices, because the electrical current can be conducted through certain wires which are conductive, which have certain conductance. So, therefore, we call it is to travel through electrical signal, or it can travel through light. If I convert these bits into form of light signals, they can also travel through a optical fiber cable. So, now that means one of the aim is that I need some transformation. That means the signals are not able to travel to a system. So, what I need is I need to convert them into a system which can carry the signal. That means the voice grade signals has to be converted into, even if I do not have a digital computer, and on telephone when I speak, the mechanical signals are converted into electrical signal by the telephone system. That is why it travels. There is no question of converting into bits and then storing, because telephone, normal analog telephone are not storing signals into bit form. They convert what I speak as a voice into signals and travel, and then the signal travels. While on the receiving side, the electrical pulses or the signals coming, and these are created or generated, converted into a mechanical form by vibration of certain material there. So, That means the telephone system is not capable of carrying the voice signals itself. Therefore, what we did, we made certain devices which convert these voice signals into electrical and carry the electrical signal. Now, that means definitely to carry an electrical signal we need certain medium, because electrical signals travel through conduction, while as electromagnetic signals may travel through radiation, where it does not need any medium. So, when I need a medium, so the medium may be the data is sent via a wire or an optical cable. So, we have different kind of cables. We can have a twisted pair cable, where two copper wires are twisted together to reduce the effect of cross talk. So, why they are twisted? If they are not twisted, their voltage levels at the end may cancel out. So, therefore, when they are twisted, they keep on changing. So, I have a Cat5, we have a unshielded twisted pair UTP, we have a shielded twisted pair. So, these are the wires which will carry electrical signals, or I can have a baseband coaxial cable of 50 ohm cable used for digital transmission, either in 10 base 2 or 10 base 5. Now, you may not see no more in the being used for the local area network. Initially, before twisted cable, these coaxial cables are very prominent, but now coaxial cables are used in television. They are broadband coaxial cables of 75 ohm, and they are used for the cable connections comes at your home through the cable operator. They are using these broadband coaxial cables. And then if you are converting into light signals, then we have fiber optical cables. And it is principally assumed that the fiber optical cables have a bandwidth of infinite bandwidth. That is what is being called, because light signals has very high bandwidth. But at the same time, it does not mean that it can carry any amount of information, because the kind of devices which we have today, they will limit that how much information or the data rate a fiber optical cable can carry. So, it is not only the cable that what its capacity, it is also the devices which are connected to that. That means, even if the cable capacity is very high, but the rate at which you convert a bit into signal is equally important. If you cannot convert with a very high rate, if you are able to convert only, say for example, 50,000 bits in a second to signals, then even if your channel can carry or your cable can carry 1000 lakhs of the bits, does not matter, because your bottleneck is your conversion devices. So, it is not only the cable capacity, it is also the intermixing of other devices which are used for transmission of signals. So, optical fibers, there are two types of it, we call multi-mode and we call single mode. Without going in details, only question is, in a multi-mode, the signal travels not in a straight line, it travels in a curved path. So, it hits the walls and then comes back and in a zigzag path, and to give the same signal strength, they are graded, all the thickness of the cable is graded, but when it comes in a what you call is a curved manner, hitting in a triangular manner like this, so it will not travel longer distance, whereas single fiber mode, the light travels straight, so it will travel longer distance. When traveling straight, you will travel longer distance. When you are traveling in a what you call in triangular shape, that is hitting up and then coming down, then hitting up then coming down, then you will not travel to a longer distance. They also attenuate, but they attenuate at a lower rate. Then other kind of mediums are unguided, where the data is sent through air. We have a line of sight communication, that means the receiver and the sender should see each other, they should be within the range of each other, straight in front of visibility. So, the light or the signal will travel straight way and it will reach to the receiver. If they are not in the line of sight, that means if the transmitting transmitter cannot see the receiving, then the signal may not meet or may not arrive at the receiver, it may deviate. So, the line of sight communication. Other is the communication satellites, if you look at, where microwaves are used and they are working as a repeater, a signal goes to the satellite and then its strength is ends and then it comes back. And then we have radio signals which are used in FM channels and ultra high frequency channel waves, and we have very high frequency waves we use in television as well. And this FM radio which is listen, and they use a bandwidth of, or we can say, and the signals from 88 megahertz to 108 megahertz. So, it has a total wave bandwidth of 20 megahertz and keep that in mind. I will talk a little later how many channels are possible, that we will talk. Now, one of the key issue is the modulation. Now, why do we go for modulation? Now, the signals which we generate and we have to use for transmission of information may not be directly carryable by a medium, number one. Second is, then what to do? That means we have to use a different signal which is to be transmitted, and that signal has to be modified by the information signal. So, if I have a voice signal of 4 kilohertz, if I want to transmit a signal of very high frequency, say for example, FM signal where I can have 88 megahertz to 108 megahertz. If I say there is a 150 kilohertz signal if I am transmitting, or 150,000 is the bandwidth signal I am transmitting, and then I have to send information in that. So, my information which I am transmitting, it lies only in the range of 4,000, but the signal which I am transmitting is in the range of say 150,000. So, now that means that the signal which I am transmitting of 150,000 frequency should carry the signal of 4,000. So, that means the 4,000 signal will modify the 150 kilohertz signal, so that when the 150,000 signal reaches at the receiving end, you can make out, demodify and then get the original signal of 4,000 and you get what information you want to do. So, the modulation is basically modifying of the carrier signal by the information signal, and then one of the important part here is the multiplexing is important, because if you look at this, what do we do? Now, when multiple users are transmitting signals, now say there is a telephone exchange. In a telephone exchange, the multiple users or multiple homes are connected at a telephone exchange. Now, there are 100 homes connected to exchange 1, and when that is happening, and each user from the home will transmit a signal of 4,000 K. So, 100 users are transmitting signals of 4,000 K at an exchange. Now, exchange has to further transmit this signal, and what will happen is, if it uses only 4,000 kilohertz signal strength, then only it will be able to transmit the signal of one user. So, that means it has to use, at this say for example, I put it like this, if it uses a signal bandwidth from 1000 to 2000 or say 10,000 to 20,000. So, one channel will be from 1000 to 1400, the next channel will be 1400 to 1800, 10,800, next will be 10,800 to 10,1200, so on and so forth. So, from 10,000 to 10,400, the 4,000 bandwidth of user 1 will be modified there, will modify that range. Then the second user signal of 4,000 will modify the bandwidth or the range of 10,400 to 10,800 and so on and so forth. So, that means what we are doing is a signal bandwidth of 10,000 to 20,000 is carrying 100 signals together by multiplexing them. So, one of the advantage of modulation is that you multiplex multiple signals and you can carry in one go. And the second is, why do we need to use higher frequency signals to carry it? If only one user is transmitting, shall I use only 4,000 hertz? It will go? No. The reason is, while signals are being transmitted and the sending antenna and the receiving antenna has a relationship. That means, the relationship of a receiving antenna is with the wavelength of a signal. If I say that the receiving antenna should have a height of 1/10 of the wavelength of the signal for which it is designed, if the wavelength is 100 kilometer, then divide by 10, then 10 kilometer, the antenna size should be 10 kilometer. Can you have a 10 kilometer antenna? No. So, that means, if I have a wavelength of say 100 meter, then I need an antenna of only 10 meter. So, then I will like to have a lower height antenna, because you cannot erect a very big size antenna. So, if I need an antenna of a 10 meter only, then I need a signal of wavelength of 100 meter. When you need a signal of 100 meter wavelength, the frequency has to be very high. Like say today you use your mobile phones, if you look at your antenna, you never see the antenna in the mobile, that is inside your mobile phone, that is which is in few centimeters or few millimeters. When it is in few centimeters a meter, say if I say it is only 3 centimeter, and 3 centimeters means I say 30 centimeter wavelength of a signal, that means I need a very high frequency signal too, maybe in gigahertz. Now, that is why the important part is I need to transmit a signal of very high frequency, and when I need to transmit a signal of high frequency, then I have to modulate. If I have to transmit a low frequency signal which contains the information, but actual transmission is done from the high frequency signal, so I have to do modulation. That is where the modulation is important. So, there are two kinds of modulation, analog and digital, and that means analog modulation, my carrier signal is analog and digital signal also in analog form. Whereas in digital, my carrier signal is in the form of analog and my digital signal is in the form of, my information signal is in the form of digital. So, that is what digital modulation means. Now, if you categorize them, in analog we have a amplitude modulation, that means the information in the signal is only represented by change in the amplitude, whereas the frequency of the signal and phase of the signal remains constant. And when you go FM channel, that is does frequency modulation, where the frequency of a signal will represent the information, the change in the frequency of a signal will represent the information, whereas the amplitude and the phase of a signal remains constant. So, when you listen to your All India radio which uses AM, amplitude modulation, when you listen to FM radio, that is using frequency modulation, and whereas in phase modulation only the phase of the signal will change, whereas the frequency and the amplitude will remain constant. Why do we go for that? If you keep in mind, the voice or the sound quality which you listen to FM radio is quite good, whereas the AM may not be of that quality. The reason is one of the reason is, any time a signal, when it is disturbed by a noise, that means the amplitude of a signal is hampered by the amplitude of a noise signal. So, the amplitude is affected. If the information is carried in the amplitude, then there is a loss of information. If the information is carried by the frequency, if the noise comes, the noise is not affecting the frequency, it is affecting the amplitude. So, the information part remains intact, it is not being changed. So, the quality is good, number one. And second is, for a frequency modulation we use very high frequency signals. Now, if you use all the frequency which you generate, then you will also hear a quality signals. Now, if you look at a binary signal here, and 3 cases I have shown here is that in amplitude modulation, the amplitude will represent the information in frequency, the frequency change here. Initially the frequency is low, then the frequency keep on increasing, that shows the information of a signal, then finally the phase of a signal changes. And accordingly, we can have a digital modulation. But the modem what you use at home is very important, that is called modulation and demodulation. See, you use a modem at home and connect the modem with your telephone line, and then one end you connect your modem with your digital computer. Now, that is what is happening is the signal from your computer, it goes, these signals are converted in digital signal, that means pulse, absence of a pulse or maybe presence of a pulse, maybe negative pulse and positive pulse represent 0 and 1. So, the pulse, say for example, negative pulse represents 1, positive pulse represents 0. So, my sequence of 0 and 1s from a computer is converted into pulse of positive and negative, and then transmitted to the modem through the cable you connect to your modem and PC. That modem is doing modulation, that the signal pulses of negative and positive is being are modifying the carrier signal which the modem generates. If it sends a signal in the range of 10,000, say for example, then these signals of pulse of positive and negative will modify the signal, and this is done modulation, and then this transmits signal to the exchange, and then exchange does the reverse process. So, what we are trying to say here is, it is a digital modulation because the information which modifies the carrier wave is a digital signal of pulse of negative and positive. So, this falls under digital modulation. Now, while you are doing this modulation, if you combine both amplitude and your phase together, then you can achieve a very high bit rate. Now, that means, if you say only 4 amplitudes are changing, so you need 2 bits to represent 4 changes of amplitude. If say 16 times amplitude changes, like 2 volt, then 4 volt, then say 6 volt, then 8 volt, 10 volt, and so on and so forth, and then up to 2 difference, then probably it may be up to 16, then you have 8 different changes. So, these 8 different changes will be represented by 2 bits, 3 bits, because one will be 00, other will be 001, so 3 bits. Now, then if you are sending 10 signals per second, 10 into 3, 30 signals you are sending the bit rate. Now, assume a case, different case I am talking about here. Now, if you combine the voltage, there are 16 changes in the volt or 8 changes in the volt, and the phase changes also twice. So, there is for each voltage change, there is 2 changes in the phases, total changes are 16 now, 8 into 2, 8 times voltage changes, and each voltage change has 2 phase changes, so 16. Now, I have 16 options. So, each 16 label will require 4 bits to represent, because 0 to 15. Now, if 4 bits, if you are sending 10 signals at a time and each signal represents 4 bits, you are sending 40 bits per second. So, by combining both the what you call the amplitude and phase changes together, you probably achieve higher bit rate. That is what the modern modems do, which you call a quadrature phase shift keying, digital modulation, which includes both amplitude and phase and more combinations of them. If you look at this diagram, what it says is that if there are 4 phases, 0, 90 and 80 and 270, and there every one has one change of phase, the dots represent your amplitude change, and 0, 90, 180 and 270, this represents your phase change. So, not much. And here the next diagram B, each phase has 4 amplitude changes, because there are 4 dots in each quadrangle. Now, similarly, if you go in the third figure, there are 4 phases, but number of dots, if you look at, there are 16 each side. So, 16, 16, 16, then you have 16 changes of amplitude for a phase. Then how many? You have 4 phases, 4 into 16, then you have 64 total changes. So, you need 8 bits to represent, 6 bits to represent a signal. So, that is how you can achieve higher data rate. Now, 2 basic standard which I talked about, what is their data rate? If you look at 232, now we do not use these serial communication cables right now, provides a good bit rate, but these are the standards if you need to use them. Now, finally, if you look at the encoding schemes, the Manchester encoding scheme and differential Manchester encoding schemes are 2 encoding schemes which are used mostly in the local area network. If you are using Ethernet, Ethernet uses Manchester encoding scheme. That is, there is a scheme how 1 will be represented and how 0 will be. It says logical 0 is represented when the voltage goes from high to low, and when voltage goes from low to high, it represents bit 0. So, when 0 comes, we say voltage will go from high to low, when 1 comes, it will go to high to low. So, that is how we will represent the signal changes. And token ring is another standard which uses Manchester differential Manchester encoding. So, these encoding schemes will be able, there are many more encoding schemes which we will not cover in this lecture. So, the 2 important are because one is used by Ethernet, other is used by differential Manchester encoding. Thank you. With this I will finish here. Thank you.
Thank you very much, sir, for this very informative lecture. It was very interesting to know about various bit rates and how the signals are transmitted. We look forward to having sir to continue this series on computer networks. So, thank you very much, sir. And dear students, this lecture will be uploaded onto the YouTube, so you can follow it up, and you can definitely write in your emails with queries and questions for Dr. Lobial, and we will be glad to answer for you. Thank you very much.
Thank you.